So for this example, we're going to be looking at whether or not animals can actually help us with detecting cancer. This might sound really weird, but think about it. We've trained them to sniff out drugs and bombs. I mean, why not cancer? So I want you to pause the video, read through the example, make sure you understand it. And now, let's go ahead and get started. First thing to realize is that I want to, for sure, do a hypothesis test. And that's because I want to conclude something. I'm dealing with proportions because, as I look through this, it's of the 54 trials, the dogs were correct 22 times. It's that out of that tells me I want to do proportions on this. So knowing I want to do proportions in a hypothesis test, let's go ahead and get started. First step is to list. When I go to list everything, I list p hat, I list n, and I list p naught. So, in this case, there were 54 trials done, n, and out of those 54, the dogs were correct 22 times. Does not look like the dogs are doing very good here. In fact, when we convert this to a decimal, it ends up that they're getting it correct about 40.74% of the time, or 0.4074 as a decimal. But before we judge them too quickly here, let's look at what P naught is. We're trying to conclude that the dogs are not just guessing. Okay, so if they're not just guessing, we need to think about, well, what would happen if they were guessing? Look at the study design here. They had the dogs smell 7 samples, and they were supposed to lay down next to the sample from the person that actually had cancer. So that is, if I put out 7 little cups of urine, and I asked you guys, go sniff those, and then lay down next to the one with cancer, what are the chances that you'd guess correctly? Well, because I'm assuming you don't have any special cancer sniffing skills, your chances of guessing it correctly would probably be like 1 in 7, right? Because you have 7 to choose from and 1 is correct. So if we were just guessing, we'd have a 1 in 7 chance, or 0.1429. Suddenly the dogs are looking pretty good, right? Let's go to step 2. Step 2 is my hypothesis. When I set up my hypothesis, I have the null and the alternative. The null hypothesis is P equals, and well, I'm going to assume in reality the dogs are just guessing, so 0.1429. For my alternative hypothesis, I copied those two things down, and then I need to figure out what goes in between them. Now let's think about what happens when you train a dog in general. When you go to train a dog, there are 2 things that can happen. 1, maybe the dog isn't trained at all, or 2, you do train the dog. But if you train the dog, there's also the chance that when you train it, you're actually training it to do the wrong thing. That is, you might think you're telling your dog to come, but in reality, your dog is just running towards you whenever you say something. For this reason, we're not going to assume we're training the dogs to do the correct thing. We're just going to compare, well, are the dogs guessing or are they not? Have they been trained to do something? For instance, maybe we trained them to actually detect who eats Cheetos or not. So because we're not saying we're training them to do exactly what we want, we're going to do not equal to. Either they are guessing or there is some type of training in here that makes it so they're not guessing. Step 3 would be my test statistic. To calculate my test statistic, I need to go ahead and find SE, and then I need to find Z. This is a great chance to practice, so why don't you pause the video, then check back in with me. Now hopefully we've come back with values of 0.0476 for SC, rounding to 4 decimal places, and 5.56 for Z. Notice that SE is kind of high, and that's because we have a low sample size, so there would be a lot of variation in between samples. And also Z is really high as well. Okay, so let's do step 4 then. Step 4 is our p-value. When we go to the p-value, I draw the bell curve, and then I go ahead and put my z-score on it. My z-score is positive 5.56, so it's in the top half. And then I shade according to the alternative hypothesis. My alternative hypothesis is not equal to. So right away, I shade the more extreme end tail. And then because it's not equal to, I go ahead and I find my other end tail, and I shade that as well. I need to find both of these, or I can just find one of them and then double it. I personally would go ahead and find the negative one every time. So I'm going to look for negative 5.56 on the z-table. Pause the video, go check it out. Okay, at this point, if you're back here, you've probably noticed 5.56 isn't on the table, right? In fact, it's so far off that our p-value, our probability, is smaller than the probability on the table. So that is, the end tail here is going to be less than 0.0002 because it's actually off the table. It's even further out than the smallest one we can find. Notice that's only one end tail, right? And so to account for this other one here, we're going to go ahead and double it because that end tail here is smaller than 0.002 and this one is smaller than 0.002. So combined, our p-value is less than 0.0004. Step 5 is our conclusion. When we go to do our conclusion, we compare our p-value always to our significance level of 0.05. In this case, our p-value is less than 0.0004. And if our p-value is less than 0.0004, that means it's definitely less than 0.05. Which means we're going to go ahead and reject H0, which is awesome. Because if we reject H0, that means there is enough evidence to suggest whatever we're trying to prove. And in this case, we're trying to prove that the dogs are not just guessing. So down here, all right, there's enough evidence to suggest the dogs are not just guessing. Now, aside from giving us our first example here of a hypothesis test with a not equal to in it, this is actually a really awesome example. In recent years, more recent years at least, it's actually been shown that dogs are really good at detecting a couple different types of cancer. For instance, there's been bladder cancer tests, there's actually been some tests on breast cancer, and also on throat cancer. And the way they do these tests are super interesting, so if it's something you might be into, check it out.